All right, so this program, we're going to do 5 times 3, which is 15. And the way we're going to do it is we're going to add 5 3 times. So first, we have 0 move into the accumulator. And then we move that data into R0. And then we have 3, which is the counter, move into the accumulator, which is then moved into R1 for temporary storage. And then we bring in 5 into the accumulator. We clear the carry bit, and then we add that R0, which is storing the sum or the product, is added to the accumulator. So basically that becomes 5, and then that result is stored back into R0. So that's where we are storing the result. Then we need to decrement the count, so we move R1 into accumulator, which is 3 goes back into the accumulator. We do clear C. We decrement the accumulator by performing this add operation. So it becomes 2, and then we move it back into R1. And then we check if the counter is 0. Since the counter is not 0, it's going to come over here, and then it jumps all the way back here, where we move 5 into the accumulator, add R0 to the accumulator, so 5 becomes 10, then move that back into R0, bring back the count, which is 2, into the accumulator, decrement it to 1, and then we repeat that process once more till the accumulator, till the count again becomes 0, and then we end the program. So that is how the program is going to move. So let's start the program. And so we need to monitor the internal resistors, and for that what we're going to do is make the switch 14 1, and we can look at the status of the internal resistors using 0, 0, 0, which will look at R0, and 0, 0, 1, which will look at R1. And speed it up a little bit. So we have that 3 come in. And so now you can see R1 is updated to 3. That's where the count is going to be held. So now the 5 has come into the accumulator. And then now we're going to clear the carry bit. The carry bit is cleared. So now we're going to do the add operation. So it's going to add the accumulator to R0 and then transfer that to R0. So that sum has gone into R0. That's holding the product. And now we got to decrement the counter. So we brought back the count into the accumulator. Then we clear the carry. So the count has gone down to 2. Then we're going to move it back into R1. So there it's updated. So that's the sum total, and that's the count total. And now we've got to check if the accumulator is 0. And since it was not 0, then it's gone to the absolute jump instruction. Now it's jumped back to 6 to start the process again. So now you can see it added the R0 to A and becomes 0A, which is 10. And so now R0 is updated with the new sum, which is 10. So now we got to decrement our count. So the count has come back to accumulator. So the count has gone back to 1. We've got to transfer that into R1. So it becomes 1. So now we're going to check again if the accumulator is 0. Since the accumulator is not 0, we see the 0 flag right here. It is not lit up. So now it goes to the absolute jump. So it's moved back to 0, 6, and we have to repeat the cycle once more. So we have the 5 coming into the accumulator. So now it's going to add 5 to 0A. To make 0F, which is 15 in decimal. Then we've got to transfer that data into R0 where the result is stored. So now we've got to again decrement the count. So that was 1, which should come into the accumulator. All right. So it becomes 0, and you can see the 0 flag has gone up, which indicates that the accumulator has 0. Let's move that. Now we check to see if accumulator is 0. It checks for the 0 flag, which is high. And then it moves all the way to 14, which is basically bringing to the end of the program. And it stays there. Looking at the data from the memory, so ADFE means it stays there.